Okay, so now we come to geometric sequences, and this is the next logical step after arithmetic sequences, and they have one main difference. Instead of adding each time to get to the next term, we are going to be multiplying by the same number every time to get from term to term. Another way of saying that would be that any term has the divided by its previous term would always give you the same ratio. Well, there's always the same ratio from term to term. Okay, so for example, we could have 2, 6, 18, 54, and so on. Okay, here you may see that I am multiplying by 3 every time. Okay, another example could be negative 3, negative 15, 75, and negative 375. Okay, here I am multiplying by negative 5 between every term. Okay, so some notation. Okay, again, just like before with arithmetic sequences, the first term is just denoted with a U1, nth term, UN, which for example means that I could say that U5 in this first example is 162 because the fifth term is 162. Okay, n just is telling us what position in the sequence your term is. Okay, and instead of the common difference in arithmetic, we have a common ratio in geometric sequences. Okay, and ratio will give us the letter R. That's what we're going to use for common ratio. Okay, and just one note on that, if you ever need to calculate that given a sequence or some info about a sequence, okay, you can just do any term divided by the previous term. Okay, because if you multiply by R to get from one term to the next, well, you can divide those two terms to get R. Okay, so again, finding a certain term and finding the sum of some terms will make up the bulk of questions about geometric sequences. Okay, so if we had to find the 12th term of example 1, well, I could call this U12, and I would say that I could start off with the first term, and I start multiplying by 3, by 3, by 3, and how many times do I need to do it? Well, it's not 12 times, it's 11 times. There's 11 gaps, if you will, between the first and 12th terms, and well, we should know by now that repeated multiplication can be written with an exponent, so 2 times 3 to the power of 11. Okay, and this is going to be 354,294. Okay, and do not be alarmed by any big numbers in geometric sequences. Okay, this is what people talk about with the power of exponential growth. Okay, these numbers grow very quickly, even if we're just starting with 2 and multiplying by 3 every time, seemingly very small numbers. Okay, repeated multiplication well, grows things very quickly. Okay, what about the 8th term of the second example? Again, I'm going to start with my first term, and I'm going to start multiplying by negative 5, and I've got to think, how many times do I do this? Well, like before, it's not 8, it's 1 less than that, it's going to be 7. And that's going to give me a negative. I've got a negative to the power of an odd number, so that will stay negative. Okay, and another fairly big number. Okay, but we should learn a formula for this, or be aware of a formula for this as well. Okay, what did I do in both of those examples to find UN? Well, I did the first term times R, and I multiplied it by R n minus 1 times. Okay, that was my formula for finding the nth term of a geometric sequence. Now, for sums, unlike arithmetic sequences, I'm not going to derive it this time. I'm just going to present you with the formula first. because it's a bit more complicated than arithmetic and would take a bit longer than we have for this video. So we have two versions of it. They're just with the order swapped round, and they're not necessarily that different. And to be honest, there's not really a great reason for having both versions, but here they are. Okay, as you would expect, just to find the sum of n terms, well, you just do u1 times r to the power of n minus 1 all over r minus 1. Okay, so if I wanted to find the sum of the first 9 terms of the first example, it'd be very impractical to try and work out the first 9 terms and to add them up. So it's good to have this formula here. So we would do 2 times 3 to the power of 9 minus 1 over 3 minus 1, which is 2. 2 and 2 will cancel out, leaving me with just 3 to the power of 9 minus 1, which is simply 19,682. Now, and is this a sensible answer? Well, if the 12th term was in the hundreds of thousands, I think it would be reasonable to expect the first 9 terms to have a sum in the tens of thousands. So I think I can trust that this answer isn't ridiculous. Okay, so then what if we had a final problem? If u3 was 12 and u7 was 3/4. In a geometric sequence, this would have to say, find u1 and r. Okay. Now we have just a relationship again between almost 4 variables, un, u1, r, and n. Okay, and the easier questions would just give you enough information to fill in u1, r, and n and ask you to find an nth term. But you may be asked to find any of the others as well. Okay, just through plugging things into the formula and rearranging, or through other just basic logical methods as well. Okay, so what we can say here is that u3 should equal u1 times r squared. And we can say that u7 should equal u1 times r to the power of 6. Now we have, well, we should be able to fill in u3 and u7 because we know what those two things equal. Okay, so u3 we can just say it's 12, u7 was 3/4. Now we have two equations with two unknowns, and we can solve it through any systems of equations method. And I might want to use substitution. So if I can make u1 equal 12 over r squared, okay, I can substitute this fraction into u1 in the other equation. So I can say that 3/4 equals 12 over r squared times r to the power of 6. Now on the right hand side here, these powers of r will cancel out to give you r to the power of 4. Okay, I will divide by 12, and I can simplify 3 over 48 to 1/16. Now I need to do the 4th power of 1/16. Okay, and you might know that 2 to the power of 4 is 16, so the 4th power of 16 is 2, and similarly the 4th power of the 4th root, sorry, of 1/16 is 1/2. Okay, so r is simply 1/2. Okay, and we can plug that into any of these equations at the start. Maybe this one would be the easiest. u1 equals 12 over 1/2 squared. Okay, 1/2 squared is 1/4. 12 divided by 1/4 is 48. Okay, so I found my u1, I found my r, So we have answered the question. Okay, and we can answer further questions about another nth term, sum of terms, or anything like that.